Change is inevitable in modern software. Changing business requirements, changing business focus, changing user profiles, changing user loads, changes in the world's economic situation. Change is coming for you. But how do you deal with change? Particularly when you're working with an event-driven system where you've got producers producing events, consumers consuming events. Imagine for a second that you've built an event-driven system and you need to make a breaking change to the version of the event. Now, we've covered that in an earlier video in this series. You're going to add a second version of the same event. You're going to depreciate the old version. Happy days, move on. But how do you actually manage that depreciation in a smarter way? Let's find out. You can have the best evolvability strategy in the world. You can have thought about every possible permutation about what your system could possibly want to do in the future. And unfortunately, you're still going to need to change your events at some point. It is incredibly unlikely that you will never need to make a breaking change to an event over the entire history of the life cycle of any software product. So how do you actually go about doing that in a smarter way? The main thing that you need to do is notify other consumers of that event that there is a breaking change coming and that the version they are happily consuming today is going to be depreciated at some point in the future. Depreciation is important because you don't want to be managing 10 different versions of the same event and not really knowing who's consuming which one. So you want to depreciate your events. The question becomes, how? How do you tell people about that? You could do things like RFCs, you could send people Slack notifications, email notifications, company-wide mail shots, but frankly, many of them may well be ignored. What you should be doing with this depreciation information is putting it in a place where people can actually use it and take action on it in a really structured way. This is the situation you're in today. You've got this order completed version 1 event that you're already publishing, and you're starting to publish this version 2 order completed event. And you need to depreciate version 1 eventually. Let's say we're going to do it on the 1st of December, 2025. What all of these publish methods do that you can see here, all they do is create the actual structure of the event. This happens to use Amazon Event Bridge. So we're creating the structure in the format that Amazon Event Bridge expects, that the AWS SDK expects. And then we're calling this publish method here. This publish method up at the top is what actually makes the call to Amazon Event Bridge, just there. And this publish method takes in this depreciation info. And depreciation info simply considers a date and a string telling you what it is superseded by. So you'll notice when this publish call is actually made for order completed V1, that you're actually passing in a new depreciation info with a date time of the 1st of December 2025. And this has been superseded by orders.ordercompleted.v2. You'll notice when you publish the order completed V2 event, that actually you're just publishing the event as it is. And this is really the best way to manage the actual technical part of evolving your system. Publish 2 versions of the same event at the same time, and then you can allow your consumers to consume the right one that they need. But what you're actually going to do with this depreciation info. So remember, we've talked in a few of the videos now in this series about cloud events. So we generate a cloud event, which is simply just a structured schema for the event that you publish. And part of the cloud event specification allows the setting of additional attributes. So as well as the standard core spec, the fields that all events should have, it also has this idea of attributes where you can add custom attributes on top of the standard specification. And what you're doing here is that if the depreciation info is not null, if the depreciation info is set, we're going to log a warning because you're publishing a depreciated event. You're going to set a tag on the publish span to say that this is a publish span for a depreciated event. And then we're also going to add to our cloud event, to the actual event that gets published, you're going to add a superseded by and a depreciation date. Now, what this means, both the telemetry that you've generated as a producer, but also the event that you publish, all contains further information about the actual depreciation. What this means then as a consumer is that you can then consume this information and choose to do something with it. If you jump over to the consumer code now, so this is the code, this is a TypeScript application that is consuming this code, and we actually have a look now at the consumer. This is a Lambda function that's consuming the message from SQS. Again, it's largely irrelevant what the actual programming language our consumer is. And the first thing we've done is extracted that cloud event specification. You can see that here. And then we're starting our process span. Part of the semantic conventions for messaging means that you should have a span for processing an individual message. So we're starting that process span. And then what you're doing is saying, if this message has a depreciation date, so if the structured cloud event that comes in has a depreciation date, then you're actually going to set some data on your process span. This is where things start to get interesting, because if you come over to your telemetry now, and you actually have a look for process spans. So here we're interested in all of the process spans across the entire system. And remember, we were just looking at the loyalty point service there. So we're interested now in this process span for the loyalty service. And if I have a look at this process span and go into the tags, you'll see that there is this depreciated one message here. So I'm actually going to update my query. I want to see all spans where messaging.message.depreciated is one. This will show me all of the spans now in my entire system that are for a message that has been depreciated. In this case, we know, because we've just been looking at it, that this is the orders completed event. And you can have a look at this order completed event. You can see the depreciation date in here. You can see that it's been depreciated. If I have a look at this span here, where I've got the actual input payload, I can even see that this has been superseded by orders.ordercompleted.v2. So I can even see exactly what the message is that is going to supersede this event that has been depreciated. And you can start to get a bit more dynamic with this. You could start to maybe run some aggregations. So maybe we want to see a list of all spans grouped by service. We want to see all of the services that are processing a depreciated message. In this case, it is only the loyalty service, because this is the only one that I've actually added the code for right now. Maybe we break this down even further. We group it by loyalty point and by messaging message.type. So you can see who's processing depreciated messages, in this case the loyalty service, and orders.ordercompleted.v1 is the type of message that is being processed that has been depreciated. Now, if you take this to its absolute extreme, because you've got the depreciation date in there as well, you could even start to set up alerts. You could have alerts and alarms that go off based on this structured data inside your telemetry. Maybe you set up an alert that says, if there's a process span for your service that has a depreciation date inside the next 30 days, you need to do something about that, because that message is going to go away. So evolvability, dealing with change, being able to depreciate messages safely is a vital part of building a synchronous system. It is one of the most common pitfalls that I see people get wrong with event-driven systems, is thinking that they can just change their events because producers and consumers are decoupled. So great, you can't. Having this structured data in your telemetry that allows you to see the consumers, but also allows the consumers to see if they're processing something they shouldn't be, will help avoid a lot of the pitfalls. Thank you for watching.